Hi, all of you. Welcome to previous year question solution class of EVS Academy. Today, we will discuss one question very important which comes from the energy and environment unit, which comes repeated in every alternative exam based on the fusion reaction. So, in nuclear energy, there are two types of reaction. First is fusion and fission. In fusion means anything which is fusing. So, two smaller nuclei fuse into one nuclear atom. There are two smaller nuclei which further fuse into one big nuclear atom is known as fusion. And fusion means breakdown. When one nuclei breaks into several smaller nuclear atoms is known as fission. So this question, very common example of fusion is from sun energy. The fusion reactions question comes in exam. So which is for 1s2, which is deuterium, and 1s3, which is tritium. Fusion reaction if desired confinement time for the ionized fuel is 2 seconds, what must be the minimum concentration of ions per meter cube for net gain of energy? Okay, confinement time is the remaining time of any ions in the reactor. So in this question, we need to measure the minimum concentration of ions per meter cube for net gain of energy. So there are basically two formulas for this. So in sun energy, fusion reaction takes place when D plus T reacts, it gives helium atom and one neutron. So you can see 1, 1, 2, 2 and 3, 5, the 4 plus 1, 1 balancing is for neutron. So reaction could be D plus T or D plus T. For D plus T reaction, which is very common reaction in sun, so the formula is confinement time into ion density. This is eta, its ion density, and T is confinement time is equal to 10 to the power 14 second per centimeter cube for D plus T reaction. Now, second one is confinement time into ion density for D plus D reaction. Okay, D plus D is 1s2 plus 1s2. Remember that. So in question, it will be given which reaction it occurs, whether it be D plus D or D plus T. For confinement time into ion density plus D plus T is equal to 10 to the power 15 second per centimeter cube. This one is very common reaction which they ask in exam. Okay, now further we will solve according to the question. So confinement time is given 2 seconds and the reaction is D plus T. For D plus T, you can see ion density into confinement time is equal to 10 to the power 14 per cubic centimeter. But in question, they have asked in meter cube. So generally they will ask into meter cube only. So what we need to do? So ion density into confinement time is equal to 10 to the power 14. Now we need to change the unit of centimeter cube into meter cube. We know that in 1 meter we have 100 centimeter. So 1 centimeter is equal to 10 to the power minus 2 meter. Okay, so it's cube. So 10 to the power minus 2 into 10 to the power minus 2 into 10 to the power minus 2. Got it? So we have changed the unit into meter cube. Now we can solve. Now confinement time into ion density, we need to measure the ion density. Ion density is equal to 10 to the power 14. Now minus 2, minus 2, minus 2. In numerator, it will be added plus 6 by 2. Okay, so it will be like 1 by 2 into 10 to the power 20. Okay, now back from the options, we can say that options are 10 to the power 19 all. So we had to calculate in 10 to the power 19. Okay, so confinement time is equal to 10 by 2 into 10⁻⁹, which will be equal to 5 into 10⁻⁹ per meter. So it is easy. Okay, so in other option, in other question, it will like you need to calculate the confinement time or ion density, whatever it will given, and D plus T reaction. For D plus T reaction, it will be 10⁻⁴ second per meter cube. In D plus D reaction, it will be 10⁻⁵ second per meter centimeter cube. So thanks for your time. We will see next doubt in another class. Thank you.